Dear participants, welcome to 7th International Symposium on Multidisciplinary Studies and Innovative Technologies. Our conference is supported by IEEE Turkey section and also Tokat Gazi Osman Paşa University. We are now in session 12.1. If you are ready, we can start with the first paper. By the way, each participant will have 10 minutes to complete their presentations. So the title of the first paper is Parhit, an innovative full-stack donation platform with dynamic routing approach in Reject.js. Are the authors of this paper here? Okay, they are not here.
Yes, yes, I am here.
Are you here? If you are ready, you can share your screen.
Yes, I can share the screen. I hope I am audible to you.
We are waiting.
Yes, am I audible to you?
Sorry, I cannot hear you.
Hello, I hope I am audible to you.
Yeah, we can hear you well.
We can hear you. There is no problem. We can hear your voice.
All right, that's great. I'm sharing. Give me half a minute. I'm sharing.
Okay, we are waiting for you.
I hope the screen is visible to you.
But your screen is visible, but we can't. Hey, yes, we can now see your presentation. You can start.
All right, all right. So the paper is titled as Parhit, an innovative full stack donation platform with dynamic routing approach in React.js. I, Shivangi Joshi, am the presenter for this paper. The content of this presentation are as follows. It consists of introduction part, then the literature review, problem statement, objectives, language and software tools that are being used, existing system issues, methodology, result, and then finally the conclusion and future scope. In the introduction part, I would like to first tell you the main motive behind the paper. So the main motive behind the paper was to explore the dynamic routing approaches that are being used in React.js, specifically to optimize the performance in the websites and to enhance the user experience. So to incorporate this, we have taken the main issue, that is the donation issue, which is not in online mode, but we have incorporated this and we have made a platform wherein donations can be made online. That is the request for the donations in several categories. Let's say the clothes, footwear, food especially, and several other things such as blood, money. In fact, all those things are incorporated. And also volunteers are also uh, being added in this. So the main idea behind this website is that it takes donation requests from the donors, and the um, the volunteers then register, and the volunteers then pick up the donations from the address of the donors. Now, the dynamic routing approach involves effective creation of the paths for the various components that are being used in the code base. This results in the reuse of the code and avoids redundancy within the whole code base. In the problem statement part, we already know that there are lack of online platforms, especially for donation drives, and so therefore web applications are needed to act as a bridge between donors and the needy ones. We know that the donation of food are also very important part, as 52% of cooked or ready to eat food gets wasted during special occasions, uh, such as festivals and other occasions as well. So there are various charitable and non-profit organizations which can benefit from a web-based solution, that is an online solution that distributes and collect donated goods, especially food items and clothing items, and then distribute it in the community where the need is required. The main objective of this paper is to design and develop a full stack donation website, as I have already mentioned. The next and the biggest objective of this platform is to register users, which can offer community volunteering and increase awareness about the donation of goods. This paper and this website wanted to build a community wherein the donors and the volunteers can meet on a single platform and share their awareness on a daily basis. Other key objectives also include validating the applicability of the dynamic routing, integrating user authentication, and data management, which can directly contribute to philanthropic initiatives and explore user engagement and impact in the online population. So, to build this full stack website, there are different technologies that are being used. First of all, for the front end, we have used HTML, CSS, JavaScript, Tailwind CSS specifically to get access to the inbuilt and predefined methods that are being offered by the technology that is Tailwind CSS. Then React.js and different routing algorithms. For backend technology, we have included server-side programming languages such as Node.js, API development, and other algorithms for building routes. Now, these technologies create a very complete and functional website. For database management, initially we have used Firebase Data Cloud Storage, which can store and retrieve product data, user information, and other order details as well. I would like to discuss the existing system issues that are present there in the society right now. That is the lack of transparency and the hidden fees and the security concerns, especially the payment issues that are going on in different donation websites available in the market. So these are some common issues that donors face due to which they are not interested in donating online. So we have incorporated transparency methods that can directly dynamically render data from the database and show it to the donors that where their donations are being transferred. The platform also ensures that user funds and personal information are secure, and it is against fraud and cyber attacks to prevent cyber attacks that are going on, especially in donations limited to payments. The main methodology, that is the main methods we have used are, first of all, I would like to explain it using this very diagram, in which you can see that there are different files that are being incorporated together. First of all, the .jsx file that consists various React components, the .html files which has the front end structure specifically for forms, then .js files, JavaScript files which are used for Firebase authentication and configuration, .css files for styling and layouting, .json files for server and client interaction. These all together builds a full stack website, which is then hosted on an online web server. The web server directly interacts with a Firebase cloud storage wherein user data, donor data, admin data, and as well as volunteering data, all of these data are being stored in this cloud. The web host then host all of this information into the internet platform, and then the clients can use this platform directly. There are different stages through which we have passed this product. Specifically, the product development life cycle is as you can see in the picture right now. First of all, the braining session consisted of knowledge representation and requirement gathering. Then the design part involved building wireframes, login page, donor page, volunteer page, home page, admin page. All of these has been designed. Finally, the development phase included integration of all these designs into one platform using various technologies. And then, after the development part, quality assurance involved feedback and testing of this product. All these things have then been deployed to the web host server. Coming on to the result part, this is just a code snippet which shows different containers that were built during the development of this platform, and the default paths and default names were also being given. Here you can see the example of how different containers can easily be created using React.js. Some of them are dot header file. This file generally contains the header section of the platform. There are different routes as well, and the default names has already been provided. This is just a code snippet to show you how React.js has comfortably been used to build the platform. The result of all these things are the website, which resulted in a robust and user-friendly platform. As you can see, this screenshot is the landing page of the developed website, where the header section and other buttons and other compatible options have been provided. This is the landing page. Now you can see here, this is the donation card in the right hand side, where selected items for donation can be easily visible to the donors. Whereas in the left hand side, you can see different categories for donating: the books, footwear, clothes, money, blood, accessories, food. These all are the categories. And under this category, users or donors can easily see the subcategories for each headings. Let's say for books, we have different options, stationery items. For footwear and clothes, we have different options as well. So donors can easily request their donations by the request donation option. And then we have this volunteer form. This is a page where volunteer details can be collected easily using their name, email, phone number, and address. This details can then be used to contact the volunteer and ask them to collect the donated or the requested donations from the donors. We also have a very important page on our platform, that is a admin dashboard, where bar graphs and pie graphs are used. Pie charts are used for visual analysis of the donors and the donated items. So on the left hand side, you can see a bar graph where admin can easily visualize the number of donations being made for each category, and pie chart has been made to represent the variation in each category and the donations that are done in them. The admin dashboard also consists of a table wherein each subcategory is easily being seen, and the information for the total number of donations that are done till now for each subcategory has been displayed. So this admin dashboard for both these things can only be visible to the admin and can only be accessed using admin mail ID. In the conclusion part, the successful creation of this application that can receive requests from donors who want to give their old things and requests from volunteers who need to volunteer in the program can be easily summarized. Additionally, the website has established a special page for volunteers where potential volunteers can sign up and submit their contact information, which will assist in the distribution and gathering of donations. The very important part of this application or the platform was the administrator dashboard, where workers access to user data and the other contributions have been made by the admin. In future, to increase transparency between donors and volunteers, the website will incorporate payment gateways that are more visible to the donors. Thank you.
Thank you for your presentation. Dear participants, do you have any questions? Okay, I guess there are no questions. We can go on with the next paper. The title of the
Yes.
paper is Design and Development of a Smartphone-Enabled Smart Card-Based Attendance Tracking Module for Personalized Education. Are the authors here?
Yes, I am here.
Okay, if you are ready, you can share your screen.
Yes, I will share my screen in a moment. Oh. Okay, can you see my screen?
Yes, there is no problem.
Okay, perfect. And can you see my slideshow?
Yes, you can start. We can see.
Okay, great. Thank you so much. All right. Hello, everyone. It is a pleasure to have the opportunity to speak in front of you all here. So thank you for this opportunity to the organizers. My name is Pavel Zlatarov, and I co-developed this with my colleague and mentor, Galina Ivanova. We are both members of the Department of Computing, or now called Computer Systems and Technologies, at the University of Russia. I am an assistant professor, and my colleague Galina Ivanova is an associate professor in the department. And we would like to present our smartphone-enabled smart card-based attendance tracking module for personalized education in front of you here today. So I would like to start with a little bit of introduction. So I'm going to start from a little bit more far. So as you know, information and communication technology has long been used in all educational levels, from primary to higher and beyond higher education. And it forms the foundation of electronic, mobile, and digital learning, e-learning, m-learning, and d-learning. So digital learning in all of its forms gained traction during the pandemic due to the need to quickly shift to online learning mode, which of course was caused by widespread institutional closures in many countries around the world. The transition wasn't without its challenges. There were access issues, trouble accessing the internet and suitable equipment. There were behavioral challenges where teachers faced unique behavioral issues with their students. There were various disruptions in the learning process, but still, the shift did happen, and in most cases, it was very successful. So electronic and mobile learning tools do allow for the facilitation of the implementation of personalized learning strategies, and that's why I do emphasize on electronic learning here, because I will talk about personalized learning. So personalized learning experiences do need to consider the individual learner's needs and learning style. And considering that, having enough data, educators should be able to adapt the content, curriculum, and other aspects of the educational process accordingly based on the individual learner's needs. Of course, personalization requires collection of data, and that data can be collected by using tests, quizzes, surveys, grade information, and data from online systems, and of course, data obtained in person in the classroom settings. So one data point that can be pretty easily obtained in both settings, but probably more easily so in the classroom setting, is class attendance. So that's why attendance tracking is a vital part of personalization, as the data about lessons and events attended can be used to identify potential weak points in the learner's profile. So attendance tracking, of course, is not something new. There are traditional attendance tracking methods, such as you see here, the paper lists, for example. Those are an example of the traditional attendance tracking methods, but they are often manual, they are labor intensive, and they can be pretty inaccurate. And even if you move the traditional forms to electronic forms, they can still be inaccurate, because the teacher can, for example, go on with their lesson and miss students who have arrived late and stuff like that. So that's why fully electronic attendance tracking is more accurate and more efficient, because errors of this type can be very easily eliminated. So when we're talking about electronic attendance management and tracking, RFID, or radio frequency identification, is very often used because it has some key advantages. It allows for quick and accurate identification of students. It has a relative low cost of implementation. It is completely relative to the setting where it's implemented. And even if we want to be frugal, I guess, even existing cards such as student IDs or other existing cards such as transport passes, for example, can be used to achieve this. So radio frequency identification, unfortunately, can require special hardware to work, but also can use commonly available devices such as smartphones, because modern smartphones have the necessary hardware to interface with RFID badges, but more on that in the next slide. So attendance tracking and smart cards. Why do we want to use smart cards? When we're talking about radio frequency identification, we can't forget to mention smart cards, because one of their interfaces is based on radio frequency identification. But smart cards have become a vital part of everyday life. They're used for identification, for payment, for access control, for telecommunications, in all, basically, not all, but many fields of everyday life and many fields of industry, and so on. Smart cards fall into different categories, which determine their functionality, their pricing, and so on. Memory smart cards are the simplest. They can only store a certain amount of data. Microprocessor smart cards are a little bit more complicated. They can, they basically contain a tiny version of a computer system inside them. They can perform some calculations, etc., etc. Cryptographic smart cards can, they are essentially microprocessor smart cards that can deal with cryptography. So yeah, we have a wide variety that can provide different functions for different systems. And of course, we also have contact and contactless interfaces, depending on how we want to read them. Contact uses electrical contacts. Contactless only requires us to present the card within a few centimeters of the card reader. Okay. Traditionally, smart cards do require special hardware, such as card readers, to communicate with the host systems. The hardware can be external or integrated in the system, but many modern mobile devices, such as smartphones, do come with integrated hardware for interacting with contactless cards. Why am I talking about smart cards? Because they can play a vital role in attendance tracking, as they provide integrity, safety, and reliability of the tracking process. And use of smart cards can lead to drastic, if implemented correctly, of course, can lead to drastic error reduction and much more rapid verification compared to other electronic attendance tracking methods. So, of course, I wouldn't be talking about all this if we didn't propose a solution to the electronic attendance tracking problem. Here, I would like to present a flexible attendance tracking system for classes, courses, and events, which we implemented as part of a personalized education system for doctoral students at the University of Ruse. So initially, it was only intended to work with standard x86-based systems and card readers, but it has since been extended to work with multiple platforms, and most importantly, smartphones, because they are so readily available. So this system makes use of Android-based smartphones and their NFC feature, which enables much wider adoption than if only used with specialized hardware. So this is an overview of the system architecture. Since this is a web-based system, we have an application server and a database which serve the system. The interaction happens through a special, well, not a special, but a web browser placed in a special mode. We can have the kiosk mode, which uses a local application and a card reader, or we can have an NFC-enabled smartphone where special hardware is not required. In the kiosk mode, students will present their card to a card reader placed near the door, for example, and as such will record their class attendance on their own. But if a kiosk or special hardware is not available, the teachers can use their NFC-enabled smartphone to scan the students' cards and basically record their attendance that way. This system is web-based. It was developed using modern web technology. You can see parts of the stack here. It's a fairly standard stack. I don't really want to go into details, so to not waste time. It does support two modes: kiosk mode, when we have a kiosk with special hardware, and smartphone mode. For kiosk mode, we do have a multi-platform local module, which works with most standard operating systems and most standard desktop computers. It's written. It has two versions. It's written in .NET and Java. The .NET version is Windows specifically. The Java version I did develop for macOS, but it works on Windows as well, and it works on Linux and other operating systems as well. So here.
Sorry, your time is finished. Please try to conclude.
Okay, thank you. So here you can see the kiosk mode and the hardware required for the kiosk mode. And here you can see some screens from the smartphone mode, which uses the smartphone's NFC capabilities. So I would like to talk about the system testing really quickly. A version of the system was live tested during an international conference taking place at the University of Russia. Each person was provided with a badge which could be scanned at kiosks and by conference staff on their smartphone. So I would like to basically go over this chart for a little bit. I just want to point out on session A, B, C, and D, there were no kiosks available, so 100% of scans were made by smartphones. And the key point here is where smartphones were used and kiosks were not available, there were no missed scans. So 100% of attendees were scanned and their attendance was recorded. Where with kiosks, people can forget and there could be missed scans. We had more kiosk scans, so attendees preferred kiosks versus mobile, but mobile did give us more scans that we could have missed if we didn't have that function. So in conclusion, attendance tracking can play a key role in personalized education if implemented correctly and enough data is collected. So considering the deficiencies of manual attendance tracking, we developed and implemented such a system at the University of Russia. It was tested at a small scale and generally well accepted with very few technical issues. It has the potential of efficient and low-cost large-scale development. And using that system, attendance data can quickly and efficiently be collected in a classroom setting. Thank you for your attention, and you can see our email addresses if you'd like to contact us.
Okay, thank you very much. The title of the next paper is XVAE MVIT Explainable Hybrid Artificial Intelligence Framework for Predicting COVID-19 from Chest X-ray and CT scans. Are the authors here?
Hi, hello. Can you hear me?
Yes, we can hear you. You can share your screen.
Okay, give me some. Okay. Can you see my screen?
Yes, we can see.
Okay, and presentation mode you can be seen.
You can start. There's no problem.
Okay. Hi everyone. My name is Daniel Adu. PhD students at University of Electronic Science and Technology, China. And today we, together with some colleagues and supervisors and mentees of ours, we are presenting on SVAE, MVIT, Unexplainable Hybrid Artificial Intelligence Framework for predicting COVID-19 from checked X-rays and CT scans. So this is going to be the outline of our presentation, talk about the introduction, our method, some experiments, results, and discussions, and then conclusion. So since its first emergence in 2019, the COVID-19 has been a global pandemic, which has affected a lot of lives and economy. In response to this, the medical community and other researchers came up with ways that we can diagnose, detect, and combat this pandemic. The primary method that was used was the reverse transcription polymerase chain reaction, the RT-PCR method, because it gives valuable insight into the genetic composition of the virus protein. But it has its own limitation. Its major limitation is the sensitivity of it is really low, between 60% and 70%. So this means that we should come up with a more comprehensive and innovative approach to tackle the virus. Fortunately, we had two imaging modalities that supplemented the RT-PCR testing, which is the computer tomography and then X-rays. They are being used to facilitate the early detection or early discovery of diseases. Regardless of this, they also come with some challenges, like in terms of the pandemic, how do we transfer the images from one point to another point? And we also have shortage of skilled personnel that they can analyze these images that we have. So we also have deep learning, which emerged in the research community as one of the viable and substantial ways that we can use to detect COVID-19. And because of this capacity to independently uncover concealed patterns in the data. But however, most of these works that use deep learning, they have some limitations. The limitation is for you to achieve high effectiveness or accuracy, then they rely on deep layers. So you have to increase the layers so that you can achieve good performance of the model. But doing that leads to higher complexity of the model in terms of the number of parameters, the flops also increase. Another limitation is the use of a single kernel size. So kernel size plays a very vital role in the way that the convolution or the neural networks work, because they directly affect the receptive field. So the larger the receptive field, the more complex patterns that we can cover. And the more complex patterns we can cover, the more features we can extract. But when you use just a single kernel, then it's either a small kernel, which cannot capture a lot, or a very large kernel, which can capture some things but cannot be able to capture other things. So with this limitation, we came up with a study. So the main focus of us was to design a lightweight framework that is desirable for practical real-world applications. So how do we do this? We explore depth-wise separable convolutions, variational autoencoders, and a multi-scale kernel. And then we couple this with the MVIT, the mobile VIT, as our classification head. So the main thing that we designed here is we designed a multi-scaled kernel depth-wise separable convolution that we integrated it into the architecture, the variational autoencoder architecture. Now, this model reduces the size, the computational complexity, and the number of parameters, as will be shown in our results. And then by using multiple kernel sizes from low to high, we are small to big, we are able to capture low and high resolution patterns in the image. So this is our method, the schematic structure of our proposed model. So our proposed framework has two parts, the encoder part and then the classification head. The encoder part is made up of 4 blocks. Each block has 2 sequential MKNDSC models. And then the main component of the MKNDSC is the MKNDSC comp layer, and then followed by the batch normalization layer, and then the railroad activation layer. Now, at the end of the encoder part, we generate latent vectors, which of dimension 256, and then we pass it to the MBIT for classification. So this is the MKNDSC model. So this is how we do it. When we get an input feature, then what we do is we split this into multiple partial tensors from xi to xn. Now, this splitting happens along the channel dimension, which means that x1 to xn, they have the same spatial dimension, but their channels will either be the same or they will differ. Then we pass each partial tensor through the convolution, which is the depth-wise separable convolution, using different kernel sizes. So if you look at our diagram here, x1 will use a kernel size j by j, x2 will use k by k, and then up to the n, which might use f by f kernel size. And then these, after the convolution, we fuse them to get the C, the original input feature of X. And then we pass it through a one-by-one convolution, and followed by element-wise addition, which is the skip connection between the input X and the output from the MKNDSC model. Now, the MVIT classification, as I said, takes the latent vector Z of dimension 256. And then this output does not fit the MVIT. So what we need to do is we have to upsample the spatial dimension to 8 by 8. And then to reduce the computational complexity, we also have to reduce the dimension to a D dimension, which we reduce it to 96. And then the MVIT will do whatever it's supposed to do some patching, and then pass the patches through the transformer encoder. And then at the end, we get the classification, which is an output of Y, an output of N. The N is the number of classes that we have here. So in our experiment, we used the loss function that we did, because we are using the variational autoencoder and we're also doing classification. We have 2 loss functions, one for the variational autoencoder and the other one for the classification itself. So we have loss for variational autoencoder, which evaluates the variational autoencoder network. The structure is given there. So we have to look at the loss of the construction. So we have to reconstruct the image, and then that will be used to train the variational autoencoder. And then there's also some divergence loss that we add to it. We use the MMD divergence loss here. And then for the classification, to predict the various pneumonia related, we use the cross entropy, which is given below. These are the training parameters that we have. So for the learning rate, optimizer, total epochs, our batch size, and the other parameters that we use. The optimized one that gives us the optimized output or result. In our result and discussion, we compared our work with 3 selected pre-trained models: VGG19, RESTED 50, AlexNet, and DenseNet 121. Then the metrics that we measured here are accuracy, sensitivity, precision, and F1. So as can be seen from the table here, the proposed model outperformed the other models across all metrics for both the datasets that we have. So our model achieved an accuracy of 96.19, a sensitivity of 96.23, precision of 96.19, and then F1 score of 96.22 for the chest X-ray. And then for the CT, we have 95.42, 95.45, 95.44, and 95.42. So this result actually tells us that it validates our model to be efficient in accurately categorizing CT data counts and chest X-ray. Then we also have the
I'm sorry, your
ROC
10 minutes
curve.
over. Please try to summarize.
Okay, so we also have the ROC curve here, which actually shows the discriminative power and then the robustness and predictive power of our model compared with the other models that we compared our work with. Then the computational complexity here, which is very important because we decided to design a model that is lightweight, which is practical in terms of real world. So the number of parameters here and the flops are very low compared to the other ones, which means that it is very practical considering the resource constraints of most medical devices that are being used in the real world. Then we also showed where our model is actually looking at. So this is the explainability of our work, showing the salience map, heat map of the model that we have. It helps us to comprehend which features in the model that the features in the image that the model relies on to formulate predictions and outcomes. So in conclusion, our research introduced an approach where we introduce a multi-scale kernel depth-wise separable convolution. And then this model helps us to leverage the innovative methodology successfully to address the limitations of the traditional convolutional neural networks that we have. And we are confident that this insight gleaned from our work will serve as a catalyst for further innovation and research in the field. So our work was sponsored by this. Thank you very much. And
thank you very much for your presentation. Dear participants, do you have any questions? Okay, there are no questions. The title of the next paper is Artificial Intelligence Framework for Skin Lesion Prediction Using Medical Dermoscopic Images. Are the authors here?
Yes, I'm here. Do you hear me, sir?
Okay, if you are ready, you can share your screen.
Okay. Okay, can you see my screen?
Not yet. Yes, we can see now.
Okay, hello everyone, welcome to our presentation. I would like to thank, first of all, the organizers of our conference. My name is Humam Abelbash, and I'm a PhD student in the Department of Mechatronics Engineering at Kocaeli University, Turkey. In our study, we proposed an artificial intelligence framework for skin lesion prediction using medical dermoscopic images. Okay, skin cancer is one of the most active types of cancer in the present decades, and it's considered as a result of uncontrolled growth of abnormal skin cells forming malignant tumors. In fact, skin cancer is primarily caused by long-term exposure to ultraviolet radiation, which can lead to mutations in the skin cells. It can occur anywhere in the body, but is commonly found on some exposed area like the hands, face, neck, and lips. In our study here, we proposed an end-to-end skin lesion prediction framework that includes data collection here to train and evaluate the proposed framework. Two benchmark medical dermoscopic datasets were collected and used. One of them is PH2 and the other is ICIC 2018. Pre-processing applying here is the pre-processing procedure is conducted to improve prediction performance After that, we do data augmentation in order to increase the training set size to meet the requirements of the AI model. Later, we use the state-of-the-art deep learning model, YOLO version 8 model, and it's adapted and fine-tuned as the core prediction component for the proposed framework. And finally, we apply the evaluation procedures in order to evaluate the results of the model. Here, in order to train and evaluate the proposed framework, two benchmark medical datasets were collected and used. The first one was the PH2 dataset, and the second was ISIC 2018, and both of them contains dermoscopic images with a segmentation of each one. And we see here an example of the images and its segmentation. So it's worth noting that the datasets we employed lacked predefined boundary boxes, but provided segmented images. As you see in the previous one, we have the images and we have the segmented images, and we don't have the boundary boxes that is useful for as a label for the model. So we employed a predefined boundary boxes in order to derive the boundary boxes from the grounded truth segmented images, and effectively creating boundary boxes here, annotation for each image. And these annotated boundary boxes actually will serve as a label for the model. So for in the input for the models, after do the pre-processing here, we get the images from the datasets, and we get also the boundary boxes that serve as the label for the model. The methodology here for the augmentation, and in order to address the problem of limited available benchmark medical dataset, we implemented a random augmentation strategy on our training data sets, included image flipping, brightness and contrast adjustments, rotations, Gaussian blur, and etc. Of course, and more. I will try to be compatible with the YOLO version 8 model. And this augmentation process not only expanded our dataset, but also ultimately contributing to the accuracy and robustness of the proposed framework. And we see here from this table that the datasets, the original datasets we get that we separated to train and testing with a number of these images. But after the augmentation process here, we get, for example, that training rather than 160, now it's 1060. And as we say, at the same procedure for the second datasets, we get more training images. And the testing images remain the same. And as you say, that it increases the accuracy and robustness of the proposed framework. And for the YOLO version 8, it's the most recent addition to the YOLO series and serves as a state-of-the-art model with capabilities spanning object detection, instance segmentation, and image classification in the realm of computer vision. We employed here transfer learning, initializing the model with predefined weights from the POCO dataset, and subsequently fine-tuning it to our dataset. The configuration parameters of the YOLO version 8 model are comprehensively detailed in the following table. From the image size, layers, parameters, learning rate, and batch size, epoch, and error stopping. We need to note here that for the second datasets, that error stopping stops at rather than 150, it stops at 28 because there's an enhancement after 28, the epoch number 28. And this is the training settings we use to train our framework. And this figure here presents the prediction results of the proposed scan lesion detection framework on the validation set using the YOLO version 8 model for the PH2 dataset. And we see that the model can detect all the legends here in the, or most of them in the images that contains in the following data sets. And with the precision was 97.5, while the mean average precision at 50 intersection over unit, it was 99.5%. Here we see that the results for the losses and precision recall and the mean average precisions over 50 or from 50 to 95. We see that there is an enhancement in the model by looking to the losses figures here and precision recall. And if we take a look to the training and validation losses, we have here the training figures, while here we get the validation on the validation data set. We see that the losses figures here, we notice that they are similar. So our model doesn't have an overfit, so it do well without overfit here. And of course, that we see that the model get improved from one epoch to another. And here, in this figure, we showcase the outcomes of the proposed scan legend detection framework predictions achieved with the model on the second data set. And the experimental results demonstrate that the model achieved scan legend detection with a precision 93.8, while for the mean average precision was 97.3. And of course, we get here for the second data set also the same results, which means that we notice that we get the model gets improved from one epoch to another. If we take a look to the losses, precision, and recall, and also to the mean average precision figures. And the same note here, we note that for the losses figure, train and validation, we see that they are similar. So our model also doesn't have an overfit on the second data set. If we take a look to the results comparison to the recent study, we see here our proposed model get for the PH2 results over precision recall and the mean average precisions get high accuracies, a high precision recall, and other matrices compared to other studies. For example, we can get for the mean average precision for the PH2, we get 0.995, while for the second data set was 97.3%. And in conclusion here, we can see that we have developed an end-to-end AI as shown in the figure here, end-to-end AI-based framework to directly detect the scan legend from the inter-input dermoscopy medical images by providing the model only with the images. And the model can detect the boxes and get the predict of the region of interest, which is the lesion region. And the achieved results, of course, validate that the effectiveness and capability of the proposed framework predicting scan lesions with a promising accuracies using PH2 dataset and the second data set. I would like to thank you for your attention and valuable time. If you have any questions, I'll be happy to answer your questions.
Thank you very much for your presentation. Dear participants, are there any questions? Okay, I guess there are no questions. Let's go on with the next paper. The title of the paper is Customer Lifetime Value Prediction Using Machine Learning to Forecast CLV and Enhance Customer Relationship Management. Are the authors here?
Yes, sir. I am present here, Mr. Gaurav Kumar.
Okay, if you are ready.
Yeah, I am sharing PPT.
Okay, we are waiting.
Yeah, it is visible now, sir.
Yeah, we can see your screen.
Yeah, it is visible now, I think.
You can start.
Yeah. Very good evening to all of you. I am Gaurav Kumar, a research scholar in the Department of CE, GLA University, Mathura. My paper title is Customer Life Value Prediction Using Machine Learning for Cost CLV, Customer Life Value and Enhanced Customer Relationship Management. And these are the content which I have present in the next introduction algorithm used in already done work in the CLV, proposed model, flow diagram, proposed algorithm, result and analysis, conclusion, future scope, and then references. First one in we have to see introduction part in today our daily life. We have to see the fast paced and highly competitive the market. Customer life value CLV helps assess the individual customer long term and earning the potential life in the customer life cycle. Lifetime value offer a roadmap for the companies use the CLV to guide and resource allocation, marketing, and customer relationship management. And then the business may be better management, customer attraction of the uncover the growth possibilities and the concerned resources of the distinguished high and low CLV customer, and we have to use the machine learning for CLV prediction and might transform the customer relationship management and CRM in the changing business context, and the machine learning may improve the CLV, establish the revealing the customer behavior and marketing the diamonding and enabling the firm engaging the consumer and boost revenue. And we have to use the research, use the varied customer data for cost CLV using machine learning for the more accurate and dynamic predictions. And we have to deeply into the techniques just like data set finding of the this study and CLV in the process and customer value and CRM strategy and the state in the individualized customer experience and real-time adaptation to help the firms succeed in the dynamic business environment. And these are having done the learning algorithm with CLV and CRM marketing the prediction. CLV using the machine learning improve the CRM resources efficiency and customer happiness and revenue with the CLV the revenue from their connections with the company. And while the traditional CLV approaches using the implicit model machine learning using the different customer data for CLV accurately, and the machine learning help the company fix complex data patterns, and the low CLV consumer just like the different higher value sectors, and whereas the high CLV customer might be the specialized marketing loyalty and the program tailors. And the algorithm done in the use of the CLV regression model, lasso, random forest, gradient boost, deep learning, clustering using the k-mean and the coax of the proportional hard model, and reinforcing the long-term model. And we our proposed model is the AIRM model is used to predict the CLV because the our a model predict to CLV because it handle the sequential data, temporal correlation, and customer behavior, the patterns, including the essential and inaccurate CLV forecasting help the organizing make product of the decision and allocate the resources. And ARIM result to clearly interpretable, helping for a stakeholder make fact and the decision on the variable relationship and CLV. And just like that, it may be used to exploit the predictive power of consumer customer data since in the versatile and adaptive the CLV data, we have the flow diagram of the ARIMA model, consider AIRM model, and these are the diagram of the ARIMA model. And our proposed algorithm we have to use in the first one is the historical CLV data over time, and output we have to see forecast the CLV value for the future periods. And first one is the data preparation, means load and process of historical CLV data, and ensuring that the time series format and visualize data to detect trends of the uh, trends of the customer using the consider difference the data stationary. And the step 2, we have to use the model selection and the analyze to autocorrelation, and autocorrelation plot of the determine the ARIMA model and order to the PDQ we have seen in the flow diagram. And third one is the we have third step a model training, a split data into the training, testing, and reversing data for evaluation and fit the RMIA model. And step 4, model evaluation, forecast the CLV for the testing period using the trained RMIA model. And we have to use the SS forecast the accuracy using the metrics just like the MSC, RAE, and RMSC, and so on. And step 5, we have to model deployed and retrain the aremia model with the entire historical data set. Once satisfied with the accuracy, utilize the aremia model and future CLV data set forecast. And sixth one is the adaptation and strategy adjustment, means continuously monitor for the model performance with a new CLV data and adapt the CRM for marketing the strategy based on the aremia inside with the optimizing resources allocation and so on. And we have to see in the step 7, reporting and visualization, means we have to create the report and visualization to communicate aremia based on CLV forecast in the site. And result we have to result and analysis to aremia model outcomes for CLV, just like that time series model evaluation. Time series in aremia model will provide the forecast CLV future time period based on the historical data. And model evaluation means and model evaluation, we have to use the model of the predictive data and sensitivity of the trend and flexibility in the adaptation and adjustment of the strategy. And observation, reporting, prediction, and historical data, and the complexity of the model and the quality of the data. And we have to see the result and analysis. We have to see accuracy and AUC ROC of the data set. We have to when we have to model applied ARIMA model and Navis, random forest, support vector machine, SVM, KNN, and so on. We have to see in this accuracy. And these are the conclusion part. Aremia model reliability, the predict the customer CLV and data driven techniques, and to analyze the forecast client and value, improve the CRM strategy and resource allocation. ARIMA excel at the temporal depends on the trends clearly in the CLV data, offering the marketing and customer return estimate. And these are the data quality and ongoing monitoring and model refinement, and need to the ARMA CLV predict because accurate and make the CRM a strategic customer life. And futuroscope ARIMA model offer a significant potential for CLV prediction and data driven strategy. The futuroscope we have to include the and more powerful machine learning and deep learning method enhancing the CLV prediction and so on. And hybrid model we have to including in future we including the hybrid model combining the aremia, time series, complexity, and the neural network, and so on. And these are the reference. And thank you.
Thank you for your presentation. Are there any questions? Okay, we can go on with the next paper.
Yes, next presentation, the next paper, my.
Okay, you will present the next paper, right?
Yeah, yes.
Okay, you can share again your screen.
Okay, I'm sharing presentation. Yeah, it is visible now.
We Yes, we can see now.
Okay, and these are the paper. Next paper title is CQoS AOMDB in the cluster-based QoS aware multi-depth and routing the protocol for mainnet using the hybrid soft computing of the techniques. And next we have to first one introduction part, our slide routing of the protocol for forward in the mainnet due to their advantage and particularly to energy of the efficiency. And mobile ad hoc, we have to use the peer to peer in the peer-to-peer, just like the self-evaluation and power generation and network adaptability. And however, the delivery of the QoS for managed application presents challenges due to the interference, signal issues, and mic layer complexities. And the challenges of managed including the untapped traffic, poor connection, and so on. And next, manage yeah, the ability of the adapt the varying of environment, and it lacks of the control, central control, make the unpredictable. And the minute proves a valuable emergency communication, and it struggle to maintain the media and concern the TCP performance and integrate with the infrastructure and network and gateway of the node in the C with the solution QoS. And we have to use the solution of the QoS connectivity and using the mainnet. And these are the related work. We have to see the paper explore the various QoS optimization and method, including the cache update, the program GA based on QR and KF MAC protocol, and the efficiency and adaptability of the uh, uh, maintain the data transfer and QoS instability. And some paper we have to see the KFMAC protocol, the state line data transfer, effectively managing the bandwidth, latency, and bit error rate with QoS system. And propose some paper we have to see in the propose as secure the multi-routing system and encryption and employing the Adobe VR product protocol and gray wolf optimization for energy efficient path selection. And some paper we have to see the result confirm the efficiency, the nature of the project with the compare existing the solution. And research gap, the paper explore the various research gap in the QoS optimization method, including the cache update to the program GA based on the QR and KFMAC protocol, and the efficiency and adaptability of the real-time cache update program in the network environment, and the sub optimality of the GA based QR and optimal efficiency clustering progress, and may impact with the long term communication. The KFMAC protocol performance was the assist with the various scenario. And the Adobe VR product protocol stands out of the comprehensive security, realized, and the flexibility compared with the new encryption methods. And our proposed model with a rapid technology with growth, Manet introduced the abnormality with the node mobility, signal strength, and routing protocol, and with the crucial communication with Manet. And QoS measurement with rapid and efficiently data transmission, and GAOMDB QoS stress the QoS with requirement with low latency with the reliability, but doesn't fully solve with QoS issues. And to enhance the QoS further with the proposed CQoS AOMDB routing with the protocol, and soft computing techniques we have to see use, and the introducing the MBA MO clustering with the optimization and HDT DNN with improved the data transfer and implementation with the ANS2 and comparison with the existing protocol including the AOMDB and GQoS AOMDB performed done and cluster based QoS aware with the multiple path routing protocol with mainnet. We the modify the MBOMO with algorithm, bird with a species with a matching the optimization with each bird representing a solution with uh, employing the polled birds and with the gains and represent the objective value and male characteristic including the monogamy and detail with the calculation with the, depending on the mating and transform the process of each bird in the algorithm. And we have to see comparative analysis of the proposed and existing routing protocols with the first one in the performance comparison over node density, and next we have to see the performance comparison over the node speed, they including the 250 to 1250 mobile node in the thousands by thousands meter square network area with the node velocity of 10 meter per second. But the performance comparison of our proposed and existing routing protocol, we have to node density including the E2E delay and energy consumptions throughout the routing overhead and packet delivery ratio and packet loss ratio. And here figure 1 we have to see the proposed CQoS AOMDB routing protocol achieve the significant lower E2E delay compared to AOMDB QoS and GQoS AOMDB. And in we have to see figure 2 so that the demonstrate reduce the energy consumption in the proposed CQoS AOMDB routing and protocol compared to existing the state of art IOMDB AOMDB QoS and QoS AOMDB protocol and so on. And next we the compare over the node speed with a node speed that test mobile speed ranging from to 5 to 25 meter per second in the thousands by thousands network area and performing the specific existing routing algorithm across the volatile the 5, 10, 15, 20 and so on, and measure the E2E delay energy consumption throughout the routing overhead PDR and packet loss ratio. Here we have to see figure number 3. We have to demonstrate that the proposed CQoS AOMDB routing protocol significant the reducing of the E2E delay compared to the QoS and AOMDB QoS and GQoS AOMDB. And here the figure 4 highlights the lower energy consumption of the proposed CQoS AOMDB routing protocol and in comparison to AOMDB QoS and GQoS AOMDB showing the sustainability of the improvements. And these are the conclusion part. We have to the proposed CQoS AOMDB routing protocol achieving 81.08% and 48.26% lower average E2E delay compared to the existing protocol in scenario with the involving node and density and node speed. And it also demonstrate of the average energy consumption that the 34.54% and 32.53% lower than the existing protocol in the node density and node speed scenarios. And next the average throughput just like the proposed protocol is 27.94% and 3.50% higher than the existing protocol in the node density and the node speed scenarios. And the average routing overhead with the CQoS node and speed the 28.23% and 23.45%, and at the last one 29.01 and 15.68% is the lower with the scenario. And these are the future scope. We have to the CQoS protocol with the mainnet research path and the performance of the accuracy with the higher density and mining the system overhead with the demand mono IoT device, and the emphasis on the security integration with the AI algorithm with the simplicity of the implementation as usability may also enable a wider application in network topology, just like the outside mainnet. And these are the reference part. And thank you.
Thank you for your presentation. Do you have any questions? Okay, there are no questions. The title of the next paper is Development and Approbation of an Android mobile application for processing space images and calculating vegetation data. Are the authors here? Okay, they are not here. The title of the next paper is Analysis of Data Balancing Techniques in Fraudulent Transaction Datasets. Are the authors here?
Yes, good evening. I'm here. Can you hear me?
Yes, we can hear you. You can share your screen.
Yes, just a moment. Share screen. Can you see my screen?
Yes, we can see, and you can start.
Good evening, everyone. Greetings from Cluj-Napoca, Romania. My name is Laura Ivanciu, and tonight I will be presenting a preview of our work and the first step in analyzing data balancing techniques in fraudulent transactions datasets. The presentation will start with a short motivation of the chosen subject. Then I will briefly describe some balancing techniques and the way we implemented them. And at the end of the presentation, I will show you part of our results, a discussion, conclusions, and some ideas for future work. As everyone knows, classical payments have many disadvantages with respect to electronic payments. There is no need for cash or paper receipts in electronic payments. Although classical payments were slow, they seemed to be more safe. And since we're trying to do everything as digital as possible, and we have less and less patience, we want everything to happen instantly. And the online interaction helps us a lot in this direction. This also gives the biggest disadvantage, so to speak, of electronic payments, which is security issues. I'm sure all of us are familiar with the most common security issues in electronic payments, such as transaction poisoning, denial of service attacks, identity theft, worms, trojans, viruses, and others of the like, phishing. But our work focuses on fraudulent transactions. So fraudulent transactions, happily, are under 1% of daily transactions. By transactions, we mean every credit card payment, payments between banks, payments from a customer using his or her account to make a payment. And there's been a high interest in developing machine learning models or AI-based models to detect and prevent such fraudulent transactions. However, the biggest challenge is to find appropriate data sets. And the problem is that since fraudulent transactions are have such a lower occurrence rate, it's difficult to find a balanced data set. All the data sets that are publicly available are highly unbalanced. This means that there are very, very few fraudulent transactions in the data set, and this means that the models will not be trained properly. So what our work proposes is to investigate which of the existing balancing techniques are the most appropriate to balance such a data set. And in fraudulent transactions data sets, we say that the majority class is represented by legitimate transactions, that is, transactions that are okay, and the minority class, which much fewer items, is represented by fraudulent transactions. Now, the most common types of data set balancing techniques are oversampling or undersampling. And this means what it usually does, meaning that is oversampling. When we're doing oversampling, we're adding more samples to the class that has fewer items. We're adding more samples to the minority class. We're creating artificial samples and adding to the minority class, while in undersampling or subsampling, we're eliminating samples from the majority class so that the majority class finally gets to have the exact number of items or samples as the minority class. There are a lot of techniques in each of these categories, but our work focused on analyzing 3 of them. 2 of them are part or derivatives out of the SMOTE with Tomek links and SMOTE with outlier elimination, and a third one falls under the other category. It's a subsampling or undersampling technique, random subsampling. So let me talk to you about the data set we used. We used the publicly available data set from Kaggle, the Kaggle platform. The data set consists of almost 300,000 credit card transactions, out of which the vast majority, more than 99%, is represented by the majority class. These are legitimate transactions, and they are labeled with 0. So 0 means legitimate, okay transactions, while the other ones, the minority class, are labeled 1, and these are what we're focusing on. These are what we're trying to make our model detect. These are the fraudulent transactions, and they are less than 0.2%, so 492. A graphical representation of the data set shows, or if it's needed, if the numbers weren't convincing enough, just look at how many legitimate transactions there are, and we can barely see a line here which shows the minority class, the fraudulent transactions. So what do we do with such a data set? Clearly, this cannot be used as a training for any model we're trying to develop. So we need to balance these classes. Before we balance the classes, we need to carefully investigate the data set, and part of this was already done. The data set was previously analyzed using PCA, principal component analysis. The data set shares the time feature for each transaction, and 28 features denoted B1 to B28. This is only an excerpt of what the data set looks like. And I'm also showing you a statistical analysis of the data set where we did some computations regarding mean value, standard deviation, minimum maximum value, number of items in in the first quarter, first half, third quarter. What we did was implement these 3 techniques: SMOTE with Tomek links, SMOTE with outlier elimination, and random subsampling. We implemented them in Python, making good use of predefined functions, and these are the results we obtained. So just to compare with the number of items in the original data set, as I said, almost 300,000 items in class 0. Just as a reminder, class 0 represents legitimate transactions, and 492 items in class 1, which represents the fraudulent transactions. By using these 3 techniques on the original data set, we got a balance between classes from the SMOTE with Tomek links technique and the random subsampling. The main difference being that by subsampling, we got the majority class, class 0, down to 492 items. And this may not be enough. This may not be enough to properly train a machine learning model, an AI model. So a first evaluation of the goodness, so to say, the performance of our data balancing techniques would be that with random subsampling, we obtain less items than would be necessary. On the other hand, by applying smoother with Tomek links, we obtained an equal number of samples in both classes, and this number equals the number in the original legitimate transactions class. Visual representation of what we observed, the precision recall score shows that the worst results, of course, were for the original data set, while Smote with Tomek links got a precision recall score that is 0.93 or 93%. Precision recall curves, which should be as close to the upper right corner as possible. In orange, we're showing the result for the Smote with Tomek links. In green, Smote with outlier elimination. These two are pretty close. A little bit towards the center of the plot, we see the result after applying random subsampling in blue, and in red for the original data set, which is far from perfect. Another way of visualizing the results would be using the receiver operating curves, which need to be as close as possible to the upper left corner. So in this plot, we can also see that the winning technique is given by the orange line, which is Smote with Tomek links. In green, Smote with outlier elimination provides similar results, and random subsampling and original data set are a bit further away. To conclude, from the three analyzed techniques, Smote with Tomek links provided the best results. Our future work includes also comparing other techniques. And finally, once we decide which one is best, we will use that to balance a data set that will be used to train machine learning AI model that aims to detect and prevent fraudulent transactions. This was my presentation for today. If there are any questions.
Okay, thank you very much for your presentation. Are there any questions? Okay, there are no questions. We can go on with the next paper.
Thank you.
The title of the paper is Computer Mathematical Support for Analysis of Stability of the Interrelation between Macroeconomic Financial Indicators and Migration. Are the authors here?
Hello, dear colleague. Are you hear me?
Yes, we can hear you. You can share your screen.
Well, can I start?
Yes, you can start. We can see your screen.
Okay, thank you very much. My name is Konstantin Strizhichenko. We are presenting our paper, Computer Mathematical Support for Analysis of Stability of the Interrelation between Macroeconomic Financial Indicators and Migration. We are present at Kharkiv National University of Economics. And in this paper, we discuss about next content about the war and VEC models scenario for the influence of migration to the macroeconomic factors. Modern trends of the national economy show that migration is a big influence to the development of the economy. Therefore, the purpose of this article is the study of the stability of the relationship between migration and macroeconomic indicator of the state's development. In our paper, we decide three main tasks. First task is formation of hypothesis about the stability. Second one is development of computer mathematical support for the study of stability, and scenario modeling for the investigation the relationship between migration and macroeconomic indicator. Provisional investigation shows that we have different factors that influence onto the stability of the interrelation between migration and macroeconomic indicators. First one is a different economy. In our investigation, we choose Germany and Poland economy. Second one is different investigation period. We took two periods from 1970 and from 1990. And third one is different type of the mathematical tools. We try use two tools, two main models, is VAR models, vector of regression models, and vector error correction models. In this case, combine these factors, we can see 6 experiments in investigation economy in different type and different content with different models. For the stability, for the investigation stability, we choose 3 main hypotheses. Hypothesis 801 is interrelation between migration and GDP don't depend from the country. Second one is interrelation between migration and GDP don't depends from the period, and third one is interrelation between migration and GDP don't depends from the mathematical models. In this case, we find different type of stability. If we accept all 3 hypotheses, we can see about strong stability of the interrelation between migration and macroeconomics factors as GDP. Also, we have medium stability must be accepts 2 hypotheses, weak stability must be accept 1 hypothesis, and unstable interrelation if nothing hypothesis not accepted. For the investigation, we used the following algorithm. From the left side, you can see the algorithmic for the construction of VAR model, and from the right side, you can see the algorithmic algorithm of the construction of the VEC model. After the construction of this type of model, we used in impulse and decomposition analysis. You can see 2 different type of impulse analysis for the Poland and Germany economy in different parts. If you see the graphs of the impulse analysis for the Poland economy, we can see that migration and GDP depends from each other with damped oscillator. But we can see interesting situation for the investigation on the national economy of Germany. For the second graphs of these models of the impulse analysis, we can see not oscillation and not damped observation of the impulse analysis. We can see it's like a trend. That means the investigation, the immigration factors had influence from the different side of the macroeconomic indicator. The composition analysis for the Poland economy shows that one of the main factors for the migration is export, but in GDP is very influenced onto the migration in VEC model. And for GDP is very important factor also is export from the country, but from VEC model is very important migration. We can see different part. If we use VAR model, we can see that export is most influence factor onto the migration and GDP. But from other side, in VEC model, that include the trend and the error currency. We can see influence of the on each other. For the VEC model, it's little bit different results. Depends from the you can compare from the VAR model. From the first graph, we can see that the oscillator influence, but from second, third, and fourth graphs, is the trend shocks onto the influence onto the national economy in migration and GDP. But when we made decomposition analysis, the factor of migration and GDP with VAR model, we can see that consumer price index have the most influence factor onto the migration and GDP. But from other side, we can see in VEC model, the interest rate is most influencer factor. It means that in VEC model exists long-term influencer, but in VAR model is short-term influence and depends from the consumer price indexes. We investigation 3 hypotheses. We can see previous on slide, and hypothesis accept yes or no. Hypothesis H01 about the interrelation between migration and GDP don't depend from the country. It was rejected. GDP and migration is most influential factor for the Polish economy, but interest rate is most influential factor for the economy. Second hypothesis about the interrelation between migration and GDP don't depend from the period. Need more investigation because the migration and GDP have weak interrelation in Germany economy. Hypothesis H 03 about the interrelation between migration and GDP don't depend from the mathematical model. Reject. We can see that war and work model got different results. In this case, we can see about unstable intercorrelation between migration and GDP. In conclusion, we can see that initial condition for chiral stability research experiments, which included three factors, were determined, such as period of study, the country of study, and a mathematical toolkit. Germany in the period and Poland in the period were chosen as the base of the study. Warrenbeck models are derivatives of these models are chosen as mathematical tools, impulse and decomposition analysis. Second one is impulse and decomposition. Dispersion analysis shows the degree of mutual influence between migration indicators and GDP was determined. A strong relation in work models between GDP and migration exists in Polish economy. It's around 15% from GDP and 27% for migration. Also, migration and GDP are second influence factor in relation in the war model, around 17% from GDP and 12% for migration. And third factor in the work model, around 8 and 4% accordingly for the GDP and migration. Opposite results were received for Germany in 1970 period. Interest rate is most influence factor on GDP. Main reason of its is the most influence of financial market and compare with labor market long-term forecasted period. Is more important for Germany because German economy more strongly than Poland economy. In that case, since long-term period is most influencing than short-term period. What we'll do in the future indicates the need for the future research for expand the sample of research and to determine the elasticity of GDP dependence on migration process. In the paper, we look co-integration in long-term period with WEG models help. Need more research of the short-term cross correlation and find the weight of long-term and short-term dynamics in various series. Thank you for watching my presentation. Do you have any question, discussion, comments? Thank you.
Thank you for your presentation. Do you have any questions? Okay, there are no questions. The title of the next paper is Index Coloring in GPenSim for Developing Colored Petri Nets. Are the authors here?
Yes, I am here.
Okay, I guess you have two papers to present.
Yes, exactly.
Okay, you can present both of your papers.
Yes, thank you. Let me now upload my, I think this is this one. Share. Okay.
Yes, we can see.
Thank you, thank you. So this is this paper is titled Index Coloring in GPenSim for Developing Colored Petri Nets. So this is basically a discrete mathematical paper for modeling discrete event systems. So I'm Reggie, and I'm a professor at the University of Stavanger in Norway. GPenSim is a tool I developed, and it is for modeling discrete systems. With the mathematics, we call it Petri nets. Petri nets are very popular for modeling and simulation of discrete systems because Petri nets is graph-based. It is very simple with simple linear algebraic mathematical background. GPenSim, my tool, is also well known because it is also simple to learn, to use, and it is being used by many people around the world for modeling discrete systems in diverse areas. However, GPenSim has some limitations. One of the limitations is the color of tokens are only ASCII strings, only text strings. So that is one of the limitations. Because of these limitations, GPenSim was not able to be used for modeling some real-world problems. So this paper is about how can we solve that problem. Okay. The solution is I name it as index coloring. So what is this index coloring? Okay. I make this paper short because the session is 90 minutes and there are 12 papers. So each paper takes about 8 minutes. So I planned this paper only for 8 minutes. Okay. So what is index coloring? Basically, it has two methods. The first method is basically rather than putting the whole data on tokens, keep the data in memory and put only the index on the tokens. So that is basically very similar to indexed memory access. Okay. For example, here is a token. Rather than putting all the data in the token, put the data somewhere in memory and only keep the index as a token color. So when this token travel around the system, it will only carry the index as an ASCII text string, not the whole data. So that will make the simulations faster and also less complicated. So that is technique one, index coloring. The second one is when two actors, two events want to exchange data. For example, T1 has to send some data to T2. T1 doesn't need to put the data as a token color. It can directly talk to T2 with the help of a mechanism called global data in gPensing. So that is the second technique. So there are two techniques, basically index coloring. The first one is indexed memory. Don't put the whole data into tokens, only the address of memory as a token color. The second one is when a transition wants to send tokens as information to other transitions, we don't have to put the information as token color, but that information can be exchanged directly with transition. So these two techniques eliminate the necessity for colors that can take advanced data types. Only with simple text strings as colors, these two techniques allow gPensing to be used to model real-world problems. As an example, as a case study, my paper talks about micro-library. Okay, here we have a micro-library. There are some users, library users, and there are some books. So this is the PetNet model. First, we introduce the users one by one, and then we introduce the books one by one into the micro-library community. Then the users can borrow a book one by one. After reading the book, they can return the book. The user becomes returnee, and the book is also returned. So this micro-library, basically, very simple events. We have to register new books. We have to register new users. Users may lend a book, a couple of books, one after the other. The users return books. So all these simple activities, if we want to develop a model to realize this simple system, we need to have some kind of advanced coloring techniques because users have their names, their addresses, their telephone numbers, other details. The books have ISBN number, the authors, and the publisher, the publication year. There are so many details. How, with very simple coloring mechanism, the user has only username and the book has only the ISBN number. How can we realize the system? it is possible with this index coloring method, where we apply two techniques. Okay. So this is the petinet. For example, this one introduces the books. This one introduces the users. This is user lending a book. This is user returning a book, and the book is returned. Okay. So this simple model is not possible in GPenSim before because of the limitation. Now with this new technique called index coloring, now we can model and analyze this kind of systems also with GPenSim. Okay. So if you want to look into the code, the complete code is available here, and the GPenSim software is also available. If you want to study GPenSim, which is used by at least 30 universities around the world, the first book is, this is a very simple user manual. Second one is an advanced book for modeling very large systems. So third book is about colored petinet, which describes the technique. One of the technique is just I described now. Okay. So that is my first paper.
Okay, thank you very much. You can go on with your second paper.
Thank you. Here it is. Let me stop sharing and reload this new paper. Here it is. How do I? Here it is. Share screen and this one. Okay. Okay. Again, this paper is also about my tool, GPenSim. This is my tool, and this is the mathematics petinets. Okay. Again, this is Reggie, and I'm a professor at the University of Stavanger in Norway. So this paper is about automatically classifying petinets. There are different types of petinets, at least around 50, 60 actively used petinet types, different type of petinets. So this paper talks about construction of a classifier that will automatically classify input petinets. If you feed a petinet into my tool, this new function will automatically identify what type of petinet it is. Okay, so that is the idea. Okay, so this petinet classifier, the new function, which I just introduced into my tool, detects the class of petinet, what type of petinet it is. Okay, and however, since this is my work, right now, the classifier only identifies the well-known classes. Also, CausalNet is a special class. The identifier, the classifier will also identify automatically causal nets. So, how do we do it? GPenSim has the extended incident matrix, which I will explain you in a minute. Using this extended incident matrix, it is easy to do the classification using simple linear algebraic techniques. So even though the classifier can only identify simple and well-known petinet types, if anybody wants to extend this classifier to identify other type of petinets, it is easy, because I give you the code which you can take and extend it to classify other type of petinets as well. Okay, so what is extended incident matrix? If you take this simple petinet, focusing on these transitions, they have inputs and they have outputs. Okay, so this is called the input incident matrix. The transition TA has one input from P1, no input from the other places. The transition TB has one input from P3 and no input from the others. So this is known as the input incident matrix. Similarly, we have output incident matrix. GPensim, my tool, has extended incident matrix, which is basically the input incident matrix and the output incident matrix put together. So that is the extended incident matrix. Okay. So let's check very simple types of pettinets. Let's start with the conservative pettinet. What is a conservative pettinet? A conservative pettinet is that if you take a transition, its input arc weights is equal to the output arc weights. Okay. For example, here we have a conservative pettinet. If you take transition T1, the input arc weight is 3. The output arc weight also 2 plus 1, 3. If you take T2, the input arc weight is 3 plus 1, 4. Output arc weights are also 2 plus 2, 4. So this is a conservative pettinet. So given the input incident matrix, how do we identify a pettinet, conservative pettinet? Just sum the row. The sum of row is equal to 3. Here, the sum of row on the right part, the left side is 3. The right side is also 3. The sum of sum of columns on the left side is 4. Also, right side is 4. If left is equal to right, total sum, then it's a conservative pettinet. Okay. Let's take one more example as a warm-up example. A state machine. A state machine is such that each transition has exactly one input and one output. Here T1 has one input and one output. T2 has one input and one output. How can we automatically detect it? Take this extended incident matrix. Each row has only one non-zero. Here it is only one non-zero, one non-zero, one non-zero, one non-zero. Therefore, it's a state machine. Let's take one more example, a marked graph. What is a marked graph? In a marked graph, each place has exactly one input and one output transition. Okay. Here, for example, P1 has one input and one output. P2 has one input and one output. P3 also has one input and one output. Therefore, this is a marked graph. How can we automatically detect it? Simple. Take this incident matrix. Each column must have only one in the sum. Here it is 1, summation is 1, here it is 1, here it is 1, and so on. Therefore, it's a marked graph. So these are warm-up exercises. But if you take a causal net, it's not that easy, okay? Because causal net have 4 different type of conditions. All places must have only at most one input transition. All places must have one output transition. Transitions should not be cold or source. That means it must have more than one input and more than one output places. There must be no cycles. So this is a causal net. So the first 3 conditions can be checked with an incident matrix, but the final one, no cycles, we need to do a little bit of more work. So all these are described in the paper. So anybody who wants, they can read my paper, okay? So here in my paper, I have realized all these functions so that we can automatically detect simple type of pettinets, in addition, causal nets, okay? The complete code is available. If you want to study the code, it is there in addition to the paper. If you want to try my software GPensim, here it is. Or if you want to read about my books on GPensim, all published by Springer, this is the simple user manual. This is advanced book on modeling large systems. And this book talks about colored patinette for modeling real-life systems. Thank you.
Okay, thank you very much for your presentation. Dear participants, do you have any questions? Okay, as I can see, there are no questions. The title of the next paper is A Comparative Study of Self-Sufficient Households with Half-Cut Solar Cells in Turkey, Antalya, Greece, and region. Are the authors here? Okay, they're not here. We have one more paper. The title of the paper is Development and Approbation of an Android Mobile Application for Processing Space Images and Calculating Vegetation Data. Are the authors here? Okay, they are not here. Mr. Abu Al-Kebbash, you can share your screen. Mr. Humam, can you hear me? Can you hear me, Mr. Humam Abu Al-Kebash? Okay, he's not hearing me. Dear participants, I would like to thank you for your scientific contribution to the Congress and hope to meet you in next Congresses. Now, I am ending this session. Thank you.
Thank you. Thank you. Bye-bye.